to understand nutrient robbing or nutrient limitations. So we're talking here about macronutrients, so nitrates, phosphates, is to understand where are nutrients coming from in the ocean. I guess there's upwelling, there's rivers, there's other sources of nutrients. And then especially into the Southern Ocean, which is the preferred ocean iron fertilization area where we could really make a difference for krills, whales, but also the climate and cool down the earth. Where are the nutrients in the Southern Ocean coming from? How are they moving? Where might they be stuck? So where can we create diatom blooms? And we can safely say these nutrients wouldn't have been productive. And which areas of the Southern Ocean have nutrients moving to areas that are not iron limited, where you probably don't have stuck nutrients? And then what might be the sort of quantitative limitations in building up these diatom blooms per year by the current upwelling that we have in the Southern Ocean? And then where can we go from there? And I think this is for many people the biggest concern, because the thinking of people is you are abusing those good nutrients for removing carbon in order to cool down the planet. And we should rather work on other climate solutions, because there we're not robbing the nutrients. And it's always like this narrative that people have in their mind, okay, if you take away the nutrients, will not be fed to fish, and then we just get the nutrients out of the cycle, and there should be as many nutrients as possible in the cycle, and the nutrients should not go into the bottom of the ocean. And I think that's a super complex topic, obviously, but
it's not,
in my mind, the one that comes up the most.
Yeah, but it's not. It's quite simple, actually. So the deep ocean is full of nutrients, has high nutrient concentrations. And the deep ocean is fed primarily by the North Atlantic, the AMOC circulation. This is North Atlantic water going down that then flows south and it fills the ocean. And then you have a few other places where you have deep water formation. And the one that oxygenates the deep ocean, the deep sea, is around in the Weddell Sea primarily, and a few other places, perhaps in the Ross Sea also, where you get bottom water that goes all the way down to the bottom. And that is going to stop, by the way, if you have a global change. Once Antarctica starts melting, the deep ocean is going to become anoxic. So what happens is that you have the North Atlantic as a major source of deep water, and then the other major source of deep water is the outer rim of the Southern Ocean. This is the Antarctic Circumpolar Current on its way around and around. It subducts. It gets overlaid by the subtropical gyres. In the subtropics, because that water is warmer and it's lighter, so this Antarctic intermediate water goes down. And this Antarctic intermediate water is the water that has gone around the continent 2 or 3 times before it subducts, or at least once, right? And we know now from measurements, we have lots of measurements from all over the place, that the concentration of nutrients going down in today's ocean is 15 millimoles. Okay, this is a number I'll come back to later, you don't have to remember it. 15 millimoles of nitrate go into the ocean. And this water is also the source water, this Antarctic intermediate water is the source water of upwelling, coastal upwelling, along the western rims of the continents, Northwest Africa and Southwest Africa, and then California, Peru, and so on. These are the upwelling, coastal upwelling, where you had this water coming up, nutrient-rich cold water. And this water is formed around the Antarctic, around the Antarctic Circumpolar Current, right? And also along the equator, the equatorial divergence also gets this water. And these are also places where you have high fish production, right? And this is where the nutrient robbing story comes from. That then the nutrients, if you take the nutrients out in the Southern Ocean, then they will be missing when they upwell. Now, okay, this might be slightly complicated, but it's easy to understand. Now, this water, which is spreading out from the northern rim of the circumpolar current and going north, it's receiving rainfall, so to speak, the biological carbon pump, the particles sinking down and dissolving and releasing their nutrients, right? Continuously. So the oldest water in the ocean also has the highest nutrients, because the younger water, as it comes up, it's freshly formed, goes down, has lower nutrients than the upwelling water. So what happens is that in the Southern Ocean, you have in the outer rim, you have 15 millimoles of nitrate going down, unused, with the phosphate also. And what is upwelling along the south, coming up, that is about 30, right? So about half the nitrate is taken up on its way north, going around and around. So it diminishes. And that water, a lot of those nutrients, they go back into the deep ocean, and there's a kind of a nutrient trap in the Southern Ocean that the water sinking out, the particles sinking out in the Southern Ocean, they dissolve and they come up to the surface again. So now the concentration of nutrients that are upwelled along the coasts are more in the range of 30, right? 30. The highest nitrate concentrations in the ocean are somewhere around 40. And they are in the 45, and they are in the North Pacific, right? So that water now has been longest at depth, and it has accumulated nutrients. Again, so you have 15 going down, and what's coming up is 30. So that means that has been filled up by particles sinking out. So if you were to keep all the nutrients in the Southern Ocean, if you had zero going down, suppose, which is not impossible, and you can't take all the nutrients out, it's possible. So even if you had zero going down, by the time that water upwells, it will have got a new charge of nutrients. Now, what about the fish? The situation today in these areas where you have this upwelling is not in the equator, because there you have continuous upwelling. So you don't have an oxygen minimum zone there. Not really, not of serious consequences. But in Namibia, in that area where you have this Antarctic intermediate water coming up, there you have massive methane production, anoxia. So bad that all the lobsters, they have photographs of all the lobsters crawling out of the ocean because they are asphyxiated, suffocated, because there's so much production. There's overproduction, and that sinks out and consumes all the oxygen at depth. You're robbing nutrients, if you call it robbing, but you're relieving the ecosystems because they have too much nutrients. So it will be better for them to have less nutrients, because then you won't have this added effect of this anoxia. By the way, I've explained that all in a paper that we published in the Philosophical Transactions of the Royal Society in 2008. It was published in 2008, yes, I think so. But we explain all this. And it's called the next generation of ocean iron fertilization experiments, where we explain all these stories. I've explained there. So people can read that paper. I think it's on the web. And we've explained that removing nutrients, reducing the amount of nutrients in the Southern Ocean from sinking out, right, is actually going to be beneficial for the climate in general, because you'll have less methane and less N2O outgassing. So that's one aspect of it. And the other aspect is that the upwelling has too many nutrients. And the other aspect, not it's the same thing, the same story, that only a small percentage of these nutrients actually get into the fish. The nutrients that are upwelling are in excess. Yeah, I mentioned that already, right? So there's too much nutrients. So if you reduce the nutrients, you're going to do good to everybody, except the anaerobic bacteria. And I don't think anybody has friendships with the anaerobic bacteria, the ones that grow in anoxic zones. I told you earlier on that the Kronos Titan company, the titanium factory in Bremerhaven, was dumping the ferrous sulfate in the North Sea in the Dogger Bank. And Greenpeace stopped it because they thought this is going to be harmful. But actually, the people who were studying it, they couldn't find any effect. There was no effect. Not even the phytoplankton concentration was higher there, because the North Sea is saturated with iron.